Okay. I'm going to start the second one over. So, VI, VF, D, A, and T. We're going to use the same technique that was in the kinematics video at the beginning of this unit. Alright, so a car is driving at 20 meters per second, and they want to pass, so they can accelerate at 5. Keep in mind that you can tell it's accelerated because of the unit, even if they didn't specify the word accelerate, right? And then he reaches a speed of 30 meters per second. And we want to know how long that will take. So we have 3 pieces of data and our unknown. We can now pick a formula from our formula sheet. All right. So the formula I'm going to use is VF equals VI plus AT. Keep in mind this is the exact same formula as this. If you expand the delta out, you get VF minus VI over T. If I rearrange that, I would get this. People goof this one up less because they don't. The danger with this one is people ignore the delta, or the most horrible thing of all is to think that delta is the same as average, and that's never true. All right, so we're going to use this formula. Okay, and so final was 30, initial was 20. The acceleration is 5 meters per second squared, and we're looking for the time. I'm going to drop units. Okay, so I'm going to subtract 20 from both sides, and I get that 10 equals 5t. Divide both sides by 5, and I get that t equals 2 seconds. Done. If this was a quiz, I would be looking for a formula with no numbers in it. 0 doesn't count as a number. And it could be rearranged or just like this. When you first put numbers into any equation, they have to have units next to them. This is good practice, making sure that the units don't match, that you don't have like kilometers per hour over here and meters per second squared over here. All right, it's also a Regents rule. And then the intermediate calculations, that's up to you, but the final answer has to have an answer and a unit. So a typical point value on a quiz would be 1 point for formula, point for correct substitution with units, 2 points for correct answer with units. Okay. All right. Move this down. Okay. Let's see. All right. Newton climbs to the top of a belfry tower. All right. I'm going to make our little data table. Okay. He drops an apple and observes it takes 1.5 seconds to reach the ground. Now, free fall questions are intimidating because it looks like they don't give you enough data. But we're on the Earth, so the acceleration due to gravity is negative 9.81 meters per second squared. Unless I have a very good reason not to, I'm going to make down the negative direction. Because I want, so if down is your negative direction, then acceleration due to gravity should be down, whether the apple is going up or down. All right, once it's in the air, it should be negative 9.81 meters per second squared of acceleration. We want to know how high the church belfry is. We're going to get that from D. And this, you need one more piece of data, and that comes from this word drops. That means its initial velocity is 0. Okay? So if you don't have enough data, keep hunting until you find hidden data in the form of an acceleration due to gravity, for example, or a keyword that tells you that the velocity is 0 at some point. Once you have 3 pieces of data and an unknown, you can pick a formula. And the formula we're going to use here is D equals VIT plus 1/2 AT squared. Okay, since 0 is times anything is 0, this whole term drops out. You could write a working version of this. So I would need one of these at least on a quiz for your first point. All right, let's plug and chug. D equals 1/2 times negative 9.81 times 1.5 seconds. Don't forget to square it. So when I do all the math on this, all right, square the 1.5, then multiply it all times this, I get that it fell 11 meters. Okay, now this is negative because the apple has a negative displacement. It's going in the negative direction. But the height of the belfry is not a displacement. That's a distance. And so the actual height, the technical answer is 11 meters. I am not too nitpicky about sign differences on something like this, as long as you realize that it is definitely falling. So if down is your negative direction, the displacement should be negative, and the heights are should be positive. All right, and then finally, what if you dropped an apple peel? Would this work? And the quick answer is no, because of air resistance. You can neglect air resistance on an apple that's traveling at reasonable speeds, but not on a feather or an apple peel or a piece of paper. Okay, next page. Okay. Dr. Culpepper was a earth science teacher at the Ithaca High School a long time ago. One of my favorite people. Haven't seen him in years, but I like to think of him when I think of this problem. All right, VI, VF, D, A, and T. Okay, so what's going on is he's throwing his pen up in the air and it's coming back down. The initial velocity is 12. We also know the velocity when it reaches the ground again would be negative 12. And we know the velocity one other place, and that's at the top. And that's 0. We can use any combination of these to find out different answers. But this is all hidden. As soon as they told us this, I knew this, and I knew this. I'm also going to make down my negative direction. All right, so the initial velocity. So I want to know how long it takes to reach his hand, okay? I could use this velocity and this velocity, but I'm just going to do the trip up because the math is easier with a 0, all right, and it illustrates some things. So I'm going to say I'm going to do the trip up, and for the trip up, the initial velocity is 12. The velocity is 0 at the top. Acceleration the entire time is negative 9.81, even when it's going up, because gravity pulls down, and down is my negative direction. And we want to know time. Okay, so I have two velocities, an A and a T. I'm going to use that same formula I've been using. VF equals VI plus AT. So let's see, 0 equals 12 meters, not 1/2. 12 meters per second plus a negative 9.81 meters per second squared times time. I'm going to subtract 12 from both sides and drop units. And I get negative 12 equals 9.81 t. So I get that time equals 1.22 seconds. That means it took 1.22 seconds to get from here to here. But we don't want to know how long it took to get to the top. We need till it reaches his hand again. Okay? If I had used this final velocity here, that would have instantly found the answer. But then you have the chance of making a sign error, right? So all I'm going to do here is just double the time. So the total time equals 2.4 seconds. Okay. All right, how high does it go? We have a choice of formulas, but I am going to do the trip down because, again, I like using 0. So for the trip down, the initial velocity is 0. The final velocity is negative 12. The acceleration is still negative 9.81. And we have the time from the first thing. And for the trip down, the time is just 1.22 seconds. It took 1.22 to get up to the top, and it's going to take another 1.22 to get to the bottom. And I'm going to, and I want D. You have a couple of choices for formulas here, all right? Because I chose trip down, I'm choosing this formula here. So D equals VIT plus 1/2 AT squared. And since the trip down has an initial velocity of 0, and 0 times anything is 0, that goes to that. So I get D equals 1/2 negative 9.81 meters per second squared times 1.22 seconds. Don't forget to square it. When I do the math on that, I get that the height was 7.3 meters, that it fell 7.3 meters, okay? Which means that it also went 7.3 meters up, because the trip up equals the trip down, all right? Couple things to worry about. If I'd put a different time in here, I would have gotten the wrong answer. It's conceivable if you put total time in here and you use a different formula, for example, this one, that you would actually get that the distance was 0. Well, the height is 0 when at total time, all right? So, warning, if you get a really tiny number for height on some problem like this, and you're like, well, it's supposed to go pretty high, but it went like 2 centimeters, that means you probably used total time. All right, this formula is not going to give it to you, but some of the formulas will give you a height of close to 0, which makes sense if you're back on the ground. All right, number 5, where I illustrate that I don't know how to spell phaser. Okay, so now we're not on the Earth anymore. We're dropping a phaser. All right, there's my terrible phaser. All right, and it's going to drop. And again, I'm going to make down my negative direction, unless I have a good reason not to. All right, so VI, VF, G, A, T. Okay, it takes 1 second to fall. The height is 6 meters. Since it's falling, though, it's actually traveling negative 6 meters. If you forget this negative, you might find yourself taking the square root of a negative number, and that should be alert that you forgot a negative somewhere. The acceleration is not negative 9.8 because we're not on the Earth. That's our unknown. And one other thing, if it's falling or it's dropped, that tells us the initial velocity is 0. So now I have my 3 pieces of data and my unknown. I can pick a formula, and I'm going to pick my favorite, d equals VIT plus 1/2 AT squared. Again, since 0 times anything is 0, this whole term drops out. I get negative 6 meters equals 1/2 times A times 1 second. Don't forget to square it. If I drop units, I get negative 6 equals, let's see, 0.5 A. Divide both sides by 0.5. And I get that A equals 12 meters per second squared. Negative, as it should be, since gravity pulls down. So if you were on Vulcan, it would feel a little bit heavier, according to this problem. All right. I'm going to do the extra credit level one on a different video.